Hi students, today we are going to see something trigonometric identities, right? And today is the last class for this concept, right? Not only for the last class for this concept alone, last class for this chapter also, right? Today we are going to see sums based on variables, right? Today we are going to sums based on variables. So they will give the variables, right? M is equal to tan theta plus sin theta and N is equal to tan theta minus sin theta, right? Tan theta plus sin theta, and they ask you to prove that m square minus n square is equal to 4 into root of mn. Already we know that m is equal to in terms of tan and sin, right? And n is nothing but tan theta minus sin theta. So we have to take the LHS, and by using the trigonometric identity or algebraic identities, we are simplifying and taking RHS, and by using that formula we are simplifying, and we have to get both LHS is equal to RHS, right? Okay, so I'm just taking that. See the question number 17. If tan theta plus sin theta is equal to m and tan theta minus sin theta is equal to n, show that, right? Show that m square minus n square is equal to 4 root of mn, right? 4 root of m into n, right? So okay, just given, see, write that given. So what is the given we are having? Tan theta plus sin theta, right? Tan theta plus sin theta is equal to m, and second one is nothing but tan theta minus sin theta, right? Tan theta minus sin theta is equal to n, and these are the givens. And what we want to prove is nothing but m square minus n square is equal to 4 times of square root of mn, right? So now I'm just going to do the proof. I'm just taking the LHS and I'm going to simplify. Already we know that m is nothing but tan theta plus sin theta. So m square is nothing but tan theta plus sin theta the whole square. So by using identity, I'm going to simplify. Same like that, n going to substitute and simplifying, right? Same thing after simplifying, right? You can stop there itself and you can take the RHS, right? RHS, and you can simplify. Finally you want to get LHS is equal to RHS, right? Nothing you are going to get changing, right? So directly you are just substituting and simplifying, right? By using that algebraic identity formula or trigonometric identities formula, we are going to simplify. Okay, I'm just taking the LHS. See proof. What is LHS? LHS is equal to, right? LHS is equal to m square minus n square, right? M square minus n square. What is m? M is nothing but tan theta plus sin theta. So tan theta plus sin theta the whole square minus tan theta minus sin theta the whole square, right? N square, n is something but tan theta minus sin theta the whole square. How it will be? It is something but a plus b the whole square, a plus b the whole square, and here how it will be? A minus b the whole square. So what is a here? A is nothing but tan theta and b is nothing but sin theta, right? Here same thing, tan theta and b is nothing but sin theta. So a plus b whole square is nothing but a square plus b square plus 2ab, and a minus b the whole square is nothing but a square plus b square minus 2ab, right? So I'm just expanding. So tan square theta plus sin square theta plus 2 tan theta sin theta, right? 2 tan theta sin theta minus, right? And this minus is common for all the terms. So put a bracket, right? I'm just putting the bracket. See, I'm just expanding these values. A plus b whole square is nothing but a square plus b square plus 2 into a into b. And a minus b whole square formula is nothing but a square plus b square minus 2ab. So see, I'm just putting a bracket. Why? Because minus is outside. So minus is common for that all three terms, right? That's why I'm just putting the bracket. Tan square theta, right? Tan square theta plus sin square theta, right? Sin square theta minus 2 tan theta sin theta, right? Minus 2 tan theta sin theta. Now I'm just going to remove the bracket by multiplying the minus inside. So it is equal to, I'm just, so see here, you can write as it is tan square theta plus sin square theta plus 2 tan theta sin theta, right? 2 tan theta sin theta minus into tan square theta minus tan square theta minus into sin square theta minus sin square theta minus into minus plus 2 tan theta sin theta, 2 tan theta sin theta, right? Got it? Now you can see that any like terms are there. Is it possible to simplify? You can simplify. Whether it is a plus, then you can add. If it is plus minus, here we can cancel it, right? So plus tan square theta and minus tan square theta will get cancelled, right? Plus tan square theta minus tan square theta. Plus sin square theta and minus sin square theta will get cancelled. Plus 2 tan theta plus 2 tan sin theta, right? Plus 2 tan sin theta plus 2 tan sin theta. Both are plus, so we can add. So plus 2 tan sin theta plus 2 tan sin theta is nothing but what is it? 4 tan sin theta, right? 4 tan theta sin theta. So this is nothing but the value of LHS. Is it any other possible to simplify? Nothing. We got a single term. See, while we are having two terms, while we are expanding, we got nearly 6 terms, right? After simplifying, we got only one term, right? We got only one term. So I'm just writing. So this is nothing but the final step of LHS. Now I am going to take the RHS. What is RHS? 4 into root of mn. So you can take the RHS. RHS is equal to 4 into square root of m into n. Right? Already we know the value of m and we know the value of n. Just substitute and simplify and try to, and you can get, you have to get 4 into tan theta sin theta, right? LHS is equal to RHS we want to get. Already 4 we are having, right? So tan theta sin theta alone it is needed. So we have to remove the root and we have to get tan theta into sin theta. Okay, you just substitute and simplify. 4 into root of, what is the value of m? M is equal to, what is it? Tan theta plus sin theta, and n is equal to tan theta minus sin theta. Substitute. So tan theta plus sin theta into tan theta minus sin theta, right? Tan theta plus sin theta. M is nothing but tan theta plus sin theta, and n is nothing but tan theta minus sin theta, right? So how it will be? Any other identity is applicable? Yes. See, a plus b into a minus b. What is a plus b into a minus b? A square minus b square. What is a here? Tan theta. What is b here? Sin theta. So it is equal to 4 into square root of tan square theta minus sin square theta. Right? A plus b into a minus b is nothing but a square minus b square. What is a? Tan theta. So tan square theta minus b square. B is nothing but sin theta. So sin square theta. Right? So see, if it is a square root of tan square theta into sin square theta means, then square root will get cancelled. Directly we can simplify. But here in between, here in the root, we are having two terms. We are having two terms, so we can't cancel the root, right? We can't remove the root, or we can't cancel the root, right? So how we are going to simplify? How we are going to simplify? See, we want to remove this minus alone. What we are needed? Root of tan square theta into sin square theta. Then square root will get cancelled. Then finally what we will get? 4 into tan theta sin theta will get it, right? That only we are needed. So how we are? It's very simple. Already we are having a very good experience while we are seeing the sums, right? So tan square theta minus sin square theta, how we are going to convert it in terms of tan square theta into sin square theta? See, just convert this tan in terms of sin cos and just do that. We will get in terms of fraction and just do the simplification. Finally, we will get in terms of the tan square theta into sin square theta, right? We will see. Okay, it is equal to 4 into square root of, right? Already we know that tan theta is equal to, what is it? We know that, what is it? Tan theta is equal to sin theta divided by cos theta, right? Sin theta divided by cos theta. So tan square theta is nothing but sin square theta divided by cos square theta, right? So instead of tan square theta, what I'm going to substitute? Sin square theta divided by cos square theta minus sin square theta. Right? So it is in the form of fraction. Now what we will do? We will do the cross multiplication. So just do the cross multiplication. 4 into square root of 1 into sin square theta minus sin square theta into cos square theta, right? Sin square theta into cos square theta, right? Just doing the cross multiplication, right? Divided by 1 into cos square theta, cos square theta. Cos square theta, right? Now how we can simplify? So root is applicable for both the numerator and denominator, right? Now I have converted the two terms in terms of one term. But we are having in terms of numerator and denominator. That we see later. That's not a problem, right? So now we have converted these two terms in terms of one term, right? Now we see that in the denominator we are having only one term. But numerator we are having two terms. Any like terms are there to simplify? How we can simplify? We are having like terms. I'm just going to take commonly outside and going to simplify, right? So it is equal to 4 square root of, right? 4 square root of. So what is the common term? Sin square theta, just taking commonly outside. So it is nothing but sin square theta into 1 minus, what is remaining? Cos square theta. 1 minus cos square theta divided by cos square theta. Divided by cos square theta, right? Cos square theta. So it is equal to, what is already we know that this 1 minus cos square theta is equal to, what is it? We know that 1 minus cos square theta equal to, what is it? Sin square theta. So instead of this 1 minus cos square theta, shall I write sin square theta? This 1 minus cos square theta is equal to sin square theta. So it is equal to 4 into square root of, right? 4 into square root of, already what is that? Sin square theta. This instead of 1 minus cos square theta, I am going to write sin square theta into sin square theta divided by cos square theta, right? I have converted in two terms in terms of one term by taking commonly outside, right? So it is equal to 4 into square root of, right, sin square theta divided by cos square theta, right? Sin square theta divided by cos square theta into sin square theta. So sin by cos is nothing but what is it? Tan. Already we know that sin square theta divided by cos square theta is nothing but tan square theta, right? So I'm just going to write 4 into square root of sin square by cos square is nothing but tan square. Tan square theta into sin square theta. Into sin square theta. See that tan square theta minus sin square theta I have converted in terms of tan square theta into sin square theta by taking LCM, right? By taking, not LCM, by doing cross multiplication, right? Converting in terms of sin cos and doing the simplification, right? Finally I got tan square theta into sin square theta, right? So now we can remove the root, right? So square root and square will get cancelled. So it is equal to 4 into tan theta into sin theta. 4 into tan theta into sin theta. So RHS is equal to, what is it? 4 into tan theta sin theta. So LHS, what is it? 4 into tan theta sin theta. So LHS is equal to RHS. Hence it is. So what is the methodology? What methodology we are doing? See, simply they are giving the variables, right? So variable that m is equal to some values and n is equal to some values, right? M is equal to some value and n equal to some value, and they ask you to prove that m square minus n square is equal to 4 into mn. Directly we are substituting and simplifying, right? One more thing you have to keep in your mind, right? See here tan theta plus sin theta and tan theta minus sin theta, so both are right terms, and directly we are substituting and simplifying. Something suppose m is something but tan theta plus cot theta and n is something but sin theta plus cos theta. Likewise different we are having means better we can convert every tan, cot, sec and cosec, right? All the trigonometric ratios just convert in terms of sin and cos, and you can substitute and simplify. It is easy to simplify, right? Understood? See here we are having like terms, right? Only symbol alone changed. Symbol tan theta plus sin theta, here tan theta minus sin theta. So I am just taking as it is and just simplifying. We got the simplification. Suppose here see, you have to keep it in your mind, right? So you have to analyze how it is possible. If you are taking directly means somewhat it will be difficult. That's why I am saying. If you're just converting in terms of sin and cos, right? If you're converting in terms of sin and cos and you just taking the LHS and simplifying, you will easily will get the simplification, right? So number 18, right? X sin cube theta plus y cos cube theta is equal to sin theta into cos theta, and x sin theta is equal to y cos theta. X sin theta is equal to y cos theta. Prove that x square plus y square is equal to 1. Just taking the LHS and we want to bring the RHS. See, LHS x square plus y square equal to 1. See, in that last sum we saw that x is equal to they have given the value, and y is equal to they have given directly, right? The value y value they have given directly. But here in this given, see the given, what is the given? First write the given. X sin cube theta plus y cos cube theta is equal to sin theta into cos theta, and one more given is there. What is that? X sin theta is equal to y cos theta, right? They have given, they didn't give the value of x directly. as well as they didn't give the value of y directly, right? So first what we have to, from the given, we want to find the value of x and y. If we are finding the value of x and y, then we can substitute and we can just applying the square and adding, we'll get the RHS. While we are simplifying, we'll get the RHS, right? So from the given, now what we want to find, we want to find the value of x and value of y, right? In terms of what is that, sine and cos, in terms of sine and cos. If after finding, then substitute and simplify, we will get the proof, right? So okay, what we want to prove is nothing but to prove x square plus y square is equal to 1. X square plus y square is equal to 1. So now I'm going to find the value of x and y in terms of cos and sine. So just see the given, x sine cube theta plus y cos cube theta equal to sine theta into cos theta. See, this x sine cube theta, shall I convert this x sine cube theta? One more given is there, x sine theta is equal to y cos theta. So x sine theta is equal to, instead of x sine theta, what I can substitute, y cos theta. Instead of y cos theta, what I can substitute, x sine theta, right? So first I am going to find the value of x. So I am just going this y in terms of x. I am just going to convert this y in terms of x. So how I am just converting, just see. So just write that x sine cube theta plus y cos cube theta is equal to sine theta into cos theta, right? Sine theta into cos theta. See, I'm just going to this, converting this, I'm just going to expand this second term. So it is nothing but x sine cube theta, right? X sine cube theta plus y cos theta, right? Y cos theta into cos square theta. I'm just splitting that cos cube into, right? I'm just splitting cos cube into cos theta into cos square theta, cos cube theta. Why I'm just splitting means, instead of this y cos theta, shall I substitute x sin theta? Understood? So instead of this y cos theta, I'm just substituting x sin theta, right? I'm just converting that all the term in terms of x for finding the value of x. It is equal to sin theta cos theta. So already we know that y cos theta is equal to x sin theta. So x sin cube theta, right? X sin cube theta plus x sin theta into cos square theta, right? Instead of y cos theta, I have substituted x sin theta is equal to sin theta into cos theta, right? Now just compare the two terms. Any common terms we are having? Yes, x we are having common, and sin we are having common. Just take commonly outside, right? X sin is common for both the two terms. Just take commonly outside. So what will get it? X sin into, right? X sin theta into, so what is the remaining in the first term? Sin square theta, right? Sin square theta plus, what is the remaining in the second term? Cos square theta. Cos square theta is equal to sin theta into cos theta, right? Already we know that sin square theta plus cos square theta. We know that trigonometric identity, sin square theta plus cos square theta is equal to 1. So instead of this sin square theta plus cos square theta, shall I substitute 1? So it is equal to, what is it? X sin theta into 1 is equal to sin theta into cos theta, right? So what we are needed? X alone we are needed. Just taking the sin theta to the RHS, then multiply will become divide. So x is equal to sin theta into cos theta divided by sin theta, right? Sin theta will get cancelled. Then x is equal to cos theta. Now we got the value of x. What is the value of x? X is nothing but cos theta, right? X is equal to cos theta. Next, we need the value of y also, right? X, we need the value of y also. Better you can take this, see that the given, you can take this as a equation number 1, and this is nothing but equation number 2, right? We know that now x is equal to, what is it? X is equal to cos theta. Substitute, right? Substitute x is equal to cos theta, right? X is equal to cos theta in equation number 2. Right, equation number 2. X is equal to cos theta in equation number 2. What is equation number 2? X sin theta is equal to y cos theta. X sin theta is equal to y cos theta. Instead of x, what I want to substitute? Cos theta, right? Instead of x is equal to, what is that? X is equal to cos theta. Instead of x, what we want to substitute? Cos theta. So cos theta into sin theta is equal to y cos theta, right? So what we want to find? We want to find the y alone. See, extra what we are having, cos theta. Taking to the LHS, then multiply will become divide. So y is equal to cos theta into sin theta divided by cos theta. So cos theta will get cancelled. So remaining what is the sin theta. So y is equal to sin theta. Now we know the value of x and y. Right, now we know the value of x and y. X is equal to cos theta, y is equal to sin theta. Now we can go to the proof. What is the proof? What we want to prove? To prove is something but x square plus y square is equal to 1. So I'm just taking the LHS. What is the LHS? LHS is equal to x square plus y square. Right, x square plus y square. What is x? Cos theta the whole square plus y is nothing but sin theta the whole square. Just apply. So cos square theta plus sin square theta. What is cos square theta plus sin square theta? We know that, right? It is equal to 1 by using it is equal to RHS. Hence it is. Understood? See, in this sum, we are getting the final proof we are getting very easily. But finding the value of that x and y only somewhat what is it? It is taking too many steps, right? Too many steps. So you have to be conscious. See, they are giving directly, you are just substituting and simplifying, and we are going to prove LHS is equal to RHS, right? If they didn't give directly, and they are giving some clues for finding the value of that variables, right? Finding the value of that variables in terms of what is that? Trigonometric ratios, right? So note down your homework sums. Sum number 19. If sin theta plus cos theta is equal to P and sec theta plus cosec theta is equal to Q, then prove that Q into P square minus 1 is equal to 2 into P, 2P, right? So I already told you that. See, P is nothing but sin theta plus cos theta, but Q is nothing but sec theta plus cosec theta. Better if this convert this Q in terms of sin and cos, it will be very easy. Right, after converting in terms of sin and cos, then you can take the LHS. Now we know the value of Q and we know the value of P. Just substitute and simplify, we'll get LHS, and we know the value of P. Just multiply by 2, then we'll get the RHS. Then we have to prove LHS is equal to RHS, right? Sum number 20. If tan theta plus sec theta is equal to A, then prove that A square plus 1 divided by 2A is equal to sec theta, right? See, the RHS we are having sec theta, right? We can't do anything. Take the LHS, we know the value of A is nothing but tan theta plus sec theta, right? Just apply, but apply that A equal to tan theta plus sec theta and simplify, we'll get the RHS, right? But I'm just giving one clue. Just convert this tan theta and sec theta in terms of sin and cos, sin theta and cos theta. It will be very easy, right? It will be very easy to get the final solution, right? For this sum, just not only for this sum alone, right? See, whenever you if you are feeling somewhat difficult to simplify, you just convert in terms of sin and cos. It will be very easy. It will be very easy, right? For this sum, for A is equal to what is it? Tan theta is nothing but sin by cos. Sec is equal to 1 by cos, right? And making us only one term by doing the cross multiply. Then we'll get the value of A. Then wherever A is coming, you can substitute that value and simplify. You will get it is equal to sec theta, right? And this is the final sum, right? I will give you more sums. I will give you more sums based on what is it? This trigonometric identities in terms of what is it? Worksheet. I will give you worksheet, right? So practice more number of sums. And this chapter and particularly this concept is very, very, very important, right? And today we are completing this chapter, and tomorrow next class onwards we are going to start a new chapter. Application of trigonometry, right? This is nothing but we are seeing that what is it? Just finding the solution, or what is it? Proofing, right? Proof. We are doing so many proofs, right? These things alone we are seeing. And next class, what we are going to see means the next chapter is nothing but application, right? Real life sums, right? Just we will find the height of the house, or height of the temple, or height of the any buildings, or what is it? Distance between the building and some people's, likewise we will find, right? So the next chapter, it is very, very easy one, right? But moreover, this chapter is the base for the next chapter, right? Base for the next chapter. We will see the introduction. We will see, while we are seeing the introduction, we will see what are the things where we are having, how we are going to solve, or how we are going to find that what is the distance and height, all those things, right? The application of trigonometry, the another name for that, the chapter application of trigonometry is nothing but heights and distance. Tomorrow we will discuss, right? Next class we will discuss, right? Thank you.